Greetings of the day. Welcome to the course on Operations Research Technique. Students, you are aware that we are in last unit, that is unit number 6, and in that we have seen the problems pertaining to aspect of simulation as a first part of this particular unit, and in last lecture I have briefed you about second topic, that is queuing theory or waiting line models, and I have explained you the importance of waiting line or why waiting lines or queues are formed in real life. We have also seen that queues are inevitable part of human life. We cannot avoid queues. There are so many situations where we come across the queues, and depending on the nature of the service, the length of the queues in service varies randomly. So one has to think in a positive way as a decision maker for optimizing the queuing system. Let's move ahead. So we'll go directly to the topic of queuing theory, wherein we have discussed in our earlier lecture this part of the unit, and we have stated each and every terminology, every word used in this particular slide, wherein we have seen the reason for formation of the queues. Just to remind you, we have seen two basic reasons why queues are formed. The number of customer exceeds the number of service facility. This is one. Number of customer exceeds number of service facilities. And second, when service facilities do not work efficiently and take more time than prescribed. When service facility do not work efficiently and take more time than prescribed. Two reasons why queues or other name to queue is waiting line. Queue or waiting line is formed. Queue or waiting line is formed. Clear? Let's move ahead. Now you can see I also expressed in my previous lecture that we want to optimize the thing, and as a service provider I am always interested in the fact of cost, because intention throughout business is to reduce cost. Then only you will increase your profit. So I want to grab these two aspects, reduce cost and increase profit. So for that you can see here a graph wherein a cost of operation versus level of service is given to us, and here two lines runs like this. One, this is cost of waiting the customer, is this line. It is in decreasing trend as the level of service is increasing in forward direction, and cost of operating the service facility per unit time is increasing. One is cost of operating the service, other is cost of waiting the customer. Both are cost. We are, as a decision maker, not interested in this alone, not interested in this alone. We are interested in this curve which takes care of total cost. And you know that if I draw a line parallel tangent to this total curve and drop a perpendicular, so this point is interest, which gives me optimum service level. So as a decision maker, as a designer, our intention should always be to go for this optimum service level. That is what one has to understand. So, as explained by me, what is content of this? Now here I have marked the important sentences with colors for your understanding. What is that? First, the total cost is minimized at lowest point of the total cost curve. So this is this point as explained. This is total cost minimum point. Since customer waiting time for service is difficult to estimate, it is usually measured in terms of loss of sales. This is very important, or goodwill. Now if I am least bothered regarding the service time, and I am assuming that let it go as it is, then what will happen? My customer will have negative mindset for my system, for my product, that this particular brand is not providing the service at optimum level, and negativity will go on multiplying, and that will affect sale of product and loss of goodwill of the organization, which is very dangerous for any organization. So looking at this aspect, you have to give best service to your customer at every point of time. Now if the customer is, now here two aspects that we have seen, one is human being and other is physical entity, and in that I have quoted as a physical entity example of material waiting for being processed or machines being waiting for maintenance purpose. So if the customer is a machine waiting for repair, that I have already explained, that is for maintenance, then the cost of waiting is measured in terms of cost of loss of production. If you are not repairing your machine within scheduled time, means machine will not be put to work for production, that will be direct loss to the organization. So waiting time for both, one is living entity, that is a customer, or a physical entity in the form of material or machine. Now this very generalized sketch to portray, to explain the waiting line situation. We know that this is the population available across globe, and the person who want to join this service, he comes from this population. So we know that the person who are willing to get the service join this on a random basis. Population joins unless and until it is prior appointment. It is random joining. I will use now the technical term random arrival of customer in system. Random arrival of customer in system. Got it? Random arrival of customer in the system, and then they become part of system. See here, now important, from this to this, it is referred as queuing system. Entire means it is part of this waiting line where the people are waiting. These are the persons, and this is service facility. This is service facility. Service facility is providing service at this point to the customer turn by turn, and after getting service, this person, they are departing from this end. So waiting line plus customer being served, person being served, forms the entire queuing system that we should understand. And as said, it is random arrival of customer in the system unless and until it is through proper appointment. Clear? Now, to understand further part, see here, in our daily life situation, we come across these 4 types of queues. The previous slide explains us what? The nature of the queue, what you mean by queuing system, entire queuing system. And queuing system comprises of waiting line plus customer being served. The total span we have noted as queuing system. So here I have tried to provide you the very basic structure of waiting line model or queuing model. In that, the very first, single channel, single phase. Now the channel here means the channel queue or waiting line. You have to be very precise. Channel means queue or waiting line, and phase means, this phase means service facility, one who is providing a service. Now here, what is the meaning of single channel, single phase? I will explain through this. Channel, single channel, see, this is channel, single channel, which is forming a waiting line or queue, and single phase, this is single phase service facility. I have written service facility, waiting line. One line, one service provider. For you, I have quoted the example here. Electric bill counter. When we are interested to pay electric bill, we go to government agency or private agency, deploy it, and there is person sitting. He is sitting in the box provided on a chair, has a cash drawer with him, stamps and everything, and we as a people join queue, and when our turn came, then we give him bill with money. He process that, he put some stamp there and give us half copy of the bill to us, and we depart from the customer. So line is formed and only one service provider is there. That is one example. Other is barber shop with one chair. We know for cutting we usually go to barber, and if that barber is having only one chair, so no option that you form a queue. Whenever your turn come, you sit on the chair, he will cut your hair or whatever operation you want to do. After that you will depart, second person in waiting will sit on the chair. Railway station with single platform. Many a times we have witnessed, particularly at villages. In for railways, we know that there is one up line and down line. So in small villages, small stations, there is only one platform on upside and one platform on downside. So the commutators, passengers has to wait on the single platform. So train arrives, stops there for few seconds, few minutes, passenger gets in or gets out of the train, and then train moves. So example, railway station with one platform, single channel, single phase. Now second, multi-channel single phase. Multi, more than one channel. More than one channel means more than one service provider. But single phase, type of service facility is only one. Nature of service facility is only one. Focus your attention on here, meaning nature of service facility. Nature of service facility. So if the barber is having more than one chair, what will do? We form, this is nothing but customer, we form queue, and then depending on the term, this is chair, barber chair, this is chair, here barber 1, here it is barber 2. What will happen? If this chair is empty, this person will go to this. If this chair is empty, this person will go to this. Now what is happening? That the line is divided into two. Line is divided into two, but the nature of the service getting is same. Nature of the service getting is same, that is cutting. So barber shop with 2 chair or railway station with 2 platforms. Similar example. 2 platforms on railway station, wherein that train, arriving train will either, if one platform is busy, the train will be halting at other platform. Clear? Third is single channel multi-phase. Now again, multi-phase here I mean more than one type of service. More than one type of service. Channel is one, therefore single channel, that is nothing but what we mean is queue is one. So best example one can understand, cash withdrawal at bank. What we usually do, we take the slip, withdrawal slip, we fill our name, account number, amount, date and proper signature, and we hand over that particular slip to the, we directly do not hand over it to the cashier, mind well, we give it to clerk. That clerk first do some processing on that, issues us a token, you must have gone through this process. Then you are supposed to wait in the waiting area, waiting zone. Then your that voucher, withdrawal slip, it goes to next head, important head, maybe at the level of manager, branch manager, not exactly branch manager, below that a senior person, signatory authority. He checks your sign, he processes whatever he want to do, he keep that process slip, withdrawal slip or voucher in a tray. Then peon comes, peon take that withdrawal slip to the cashier. Then cashier attains that particular slip, he put seal on that, he asks you to again sign on the withdrawal slip, and then he gives or pays you the cash which you have demanded. So your withdrawal slip or withdrawal voucher has gone you are part of queue. Like you, there are so many persons behind you who have applied for withdrawal, cash withdrawal. They are also sitting with you, but your that particular slip is going through these number of stages. Queue is same, but here, as I have explained, very important concept. This is service facility 1, this is service facility 2, this is service facility 3, like that, and then departing customer. This is one example. Other example I will quote is of assembly line. Suppose we are considering assembly of motorcycle and there is conveyor. At one point the chassis of the motorcycle is loaded, and then with proper conveyor speed that chassis is passed through different stations, and at different stations operators are assigned to fit their component as per standard SOP, and at every stage the worker is doing his job, and at the end you get complete motorcycle as a output at other end. So the chassis which is mounted on the first station, same is processed at different service facility 1, 2, 3, 4, like that, and taken away. So single channel, single queue, but multi facility. Other example I have given. Third example, third category is multi-channel, multi-channel, multi-phase. Very important. Multi-channel, multi-phase. So first a single line, single channel, but then divided into two. Since divided into two, it is called as multi-channel and multi-phase. Why? That is very important to understand. This is service facility 1, this is service facility 2, this is service facility 1, this is service facility 2. So students, same line bifurcated, and you are getting services, different services at two various lines. So best example is two or organization with two or more assembly line, or must have witnessed checking facility at airport. Different checks are required when you travel through airlines. Security check, immigration check, your ticket checking, Aadhaar checking, every now and then you are required to go through different queues, and initially one form line is divided into different lines. So these are in the real life the basic structure of waiting line model we come across. Now this is again the important figure which portrays major components or elements of queuing system. Now see here, the terminology is important. One is calling population, we'll explain all of these, then queuing process, queue discipline, and service process. So it is because queues are formed, we have to serve the queues to optimize in an optimized way, and this queue discipline portrays or displays the order in which, the nature in which queues are handled, process. You can see over here very important concept. As we have seen in previous slide, the person interested in queue will join through calling population. If you recall that I have given this sketch and I have drawn some like this. So these persons are coming from this population. Then they form the part of Q. They form the part of Q. Then they go through, here you can see this dotted area shown as one waiting area, then servicing area, and here also the queue is going in the disciplined way, and after that it is the person service customers, means after being part of this system they are departing one after other. That is in general mechanism, and we have seen in our earlier slide also, this particular area is referred as our queuing system. If you recall earlier sketch. Now here you can see here three important words. One is bark, second is lineage, third is jockey. Very, very important. See, our entire behavior of system depends on this attitude of, I am saying these three is attitude of customer. We'll explain. This is nothing but the attitude. Instead of attitude, we'll say it as not exactly attitude, it is behavior of customer. And see, population is coming, joining the process, barking, waiting for some time. Again, this is where he before joins, barking at initial stage, being the part of the system for some time, reneging, and jockey. It is joking nature. I will explain all these three concepts one by one. You must have witnessed a scenario where parallel queues are there in real life, particularly in railway ticket reservation counter, and particularly when season is on, long queues are there with 4 to 5 counters, reservation counters, and queues, long queues with say 30-40 persons in one queue. Lot of hodgepodge is going on, and there are some persons in the queue, they shift the queue as and when they feel, that they jump from one queue to other to third to first, like that. That is called a joking nature of the customer, because they have intuition in their mind that the queue in which they are standing is not fast one. They feel the side queue, this side queue or this side queue is working fast. Maybe sometime it is true, but the person who was in the queue is like jumping from one queue to another. That is called a joking nature of the customer. We'll see these three terms in detail. See here, calling population characteristics takes care of these three parameters: size of calling population, behavior of the arrival, and pattern of arrivals at the system. Now, under this size of calling population, what do you mean by calling population? The calling population need not be homogeneous. You never know. And it consists of several subpopulations. For example, the very good example, a patients arriving at OPD of hospital are usually in 3 categories. Very important statement. We are conversant with outdoor patient department, which is abbreviated as OPD. In OPD of any hospital, particularly in government hospital, the patients came in 3 categories: walk-in patient, patients with appointments, and emergency patient. Usually these 3 categories of patients came for treatment. Now, priority of each category is different. Priority of each category is different. The treatment required, service time required for each category is different. So that takes care of this calling population. Each patient class places different demands on service facility, but waiting expectation of each category differ significantly. Emergency patient cannot wait for a long time. Patients with appointments, yes, they say that they took prior appointment. And walk-in patient, yes, you came on 11th hour, you have to wait there. So depending on this, system works. Now, size of calling population talks of 2 things that we have already seen. If probability of arrival depends on the number of customers already in the system, the calling population is called as limited or finite. Machine operator responsible only to handle 5 machines. Salesman responsible to handle limited number of customers. Limitations are there, so that is called as finite. Other cases, alternately, if probability of arrival does not depend, when it is not dependent, it is referred as unlimited or infinite category. That is the case. In third, now when we talk of behavior of the customer behave in 2 ways. One is a patient customer and another category is impatient customer. One is patient customer, another is impatient customer. Machine arrived at the maintenance shop are examples of patient customer. You have to give priority to it. Whereas a customer who has just arrived at a grocery shop finds that salesmen are busy in servicing. When we go to grocery shop, we many a times find that salesman is handling different customer, but as a customer we want immediate service from the salesman and we are irritated. We then leave the shop and we think that we will move to other shop. So that customer is referred as impatient customer, whereas this category is referred as patient customer. Now, these 3 important behavior of the customer. One is barking, another is reneging, and third is joking. So when a customer becomes part of the system, when it is called as barking, customer do not join the queue. Customer is not joining the queue either by seeing the number of customer already in the service system or by estimating that excessive waiting time for the, he observed the system from far distance, been to the queue but hesitate to join the queue, and his mind says, okay, I will not be part of system, I will leave the system. That aspect is referred as barking. In second case, reneging, the customer, he joins the system. Joining the system, wait for some time in the queue. He waits for some time in the queue before being served. he is not in the system. He is in the system, wait for system, but in the middle leaves it. Joking. Customer move from one queue to another, hoping to receive service more quickly. And this I have already explained that this particular scene is more common. One can always witness this scenario at railway station. Always witness this scenario. So this is behavior of the customer, and if this customer behaves like this haphazardly, so it is impossible for a system designer to design proper system. One has to take that aspect in mind. Now, pattern of system arrival. We have seen that in real life, the arrivals, they join system from population. So customer may arrive in batches, depends. If it is they are going to mall or to a movie, they go in batches. But if we want to have a particular service, then we go individually. For hair cutting, I never go with my family. I go alone. For railway reservation, we are not going as a family as a whole. We are going individually. So it depends whether we are joining the system in batch, such as arrival of family at a restaurant, good example, or individual, such as arrival of a train at a platform. Customer may arrive at service facility either on scheduled time by prior information or unscheduled time with the information. Now one thing you have to keep in mind, that we come across with the arrival of this customer, and for calculation purpose usually 3 types of distributions are taken care of in mathematical analysis. First is Poisson's, second is exponential distribution, and third is Erlang distribution. Basically the model which is in our syllabus talks or takes care of this first model, that is Poisson's distribution. So in our model, arrival of the customer will be as per Poisson's pattern. Now this is again the important aspect in servicing. Anybody in real life will be waiting with this first concept, that is FIFO, first in, first out. Any individual will like the attitude of, if I become the part of the system, as a first customer, I should be served first. One who is following me should be treated next, and the last person who has joined queue should be treated last. In general, by default, for any system, unless and until it is specified, the rule should be first in, first out. Many a times we observe this mechanism, that the person who joins in the initial period will be given priority. So system, any individual will like that one should follow the system of category first in, first out. Second is last in, first out. This is the bias system which in general people don't like. Suppose I am standing in a reservation counter and I am on the way of getting my turn right now, or I am just one customer behind, and a person who I am in that waiting line for 4 hours, and the person who is just coming at 11th hour, he joins the queue ahead of me and being the part of system and get his reservation done. Nobody will like that attitude. That is said as last in, first out. Students, remember in mind, in real life we cannot avoid this situation. Many a times we have to follow this situation of LIFO, particularly in lorry loading. If we are taking example of lorry loading, in lorry loading we load items in the lorry one by one, and last item is kept at the back, and then we unload the component from the lorry. We never follow the system that okay, we will remove the item which is loaded first in the front. So there at that point it is essential that you have to unload the items which you have placed in the lorry in the last phase. Similarly, you as a student, when you return book to the counter, library counter, the person sitting there, he keeps all the books aside, and when the next student come and ask the same book which is kept aside, the librarian never does like that. He is not issuing the book which he has received, and he is going to the shelf, picking the book and then issuing, saying that this book is just arrived. There we have to use the concept of LIFO. Similarly, in case where we are piling the commodities in stacks one over other, so while removing, we are not removing this from the bottom, we have to remove the stack which is loaded last. So that is LIFO. Next is serve in random number 0. So this is what I example usually quote is, it is God's call to the population that serve in random number, no priority in the order of system. And this is particularly, as you can notice, priority queues, where we go by appointment, for queues for ladies, queues for physically disabled, like that. So you have to respect those person, those categories for the related queues. So these queues disciplines must be followed in real life for analysis purpose. And these are the various notations. So what we'll do right now, we'll stop our lecture at this point of time. From next lecture, we'll go through all these notations and we'll solve problem pertaining to this concept. Till the time you study the basic concept of waiting line model. So today I am ending this lecture.